In today's digital landscape, data reigns supreme. Websites and applications rely heavily on databases to store and manage sensitive information like user credentials and financial records. SQL injection, or SQLI, is a common yet potent web vulnerability that can have devastating consequences if exploited. Imagine a hacker gaining unauthorized access to your website's database, potentially compromising the personal information of thousands of users. SQLI preys on vulnerabilities in how web applications interact with databases, allowing attackers to manipulate back-end systems and steal, modify, or delete valuable data. Unlike other attacks that might cause visible disruptions, SQLI often operates silently in the background. Understanding how SQLI works and the different forms it takes is crucial for developing effective defense strategies. To understand how SQL injection works, we need to delve into how web applications interact with databases. SQL, or structured query language, is used to communicate with databases. It enables web applications to retrieve user data or process payments. When a user interacts with a web application, it sends SQL queries to the database. SQLI exploits vulnerabilities in these queries. Attackers manipulate input fields to inject malicious SQL code. For example, a login form with fields for username and password. A typical SQL query might look like this. Select asterisk from users where username =, user underscore input underscore username, and password =, user underscore input underscore password. If not sanitized, an attacker could enter a malicious string like admin. This changes the query structure, bypassing authentication. By injecting malicious code, attackers can execute unintended commands, granting them unauthorized access to sensitive data. SQL injection attacks come in various forms, each with its own unique characteristics and methods of exploitation. In-band escalate. The attacker retrieves data directly through the vulnerable application. Blind SQLI. The attacker infers information by observing the application's behavior without seeing the results of the injected query directly. Out-of-band SQLI. This technique uses the database server's capabilities to communicate with external systems. Error-based SQLI. Attackers exploit error messages generated by the database server to gather information about the database structure. Union-based SQL. This technique uses the union SQL operator to retrieve data from different tables within a database. These are just a few examples of the many types of SQL attacks. Attackers are continually devising new ways to exploit vulnerabilities. Understanding these different types is crucial for implementing comprehensive security measures. Real-world consequences, notable SQL injection attacks. History is rife with high-profile data breaches where SQLI played a pivotal role, costing companies millions of dollars. One such example is the Heartland Payment Systems breach of 2008, where attackers exploited an SQLI vulnerability, gaining access to 130 million credit card numbers. Another notable example is the PlayStation Network outage of 2011, where an SQLI attack stole personal information of over 77 million users and brought down the entire network for weeks. These examples demonstrate the devastating consequences of SQLI attacks. From large corporations to small businesses, no one is immune to this threat. The financial, reputational, and legal ramifications of such breaches can be crippling. Implementing robust security measures is critical to mitigate the risk of SQLI. Building defenses, protecting against SQL injection. Implement robust security measures to prevent SQL injection attacks. Validate all user input to block malicious code. Use output encoding to prevent code injection. Prepared statements with parameterized queries are essential. Implement a web application firewall to filter malicious traffic. Regular audits and staying informed are crucial for security. Staying ahead of the curve, ongoing vigilance. SQLI is not a static threat. Attackers constantly devise new ways to exploit vulnerabilities. Continuous education and awareness are crucial. Regular training programs and security awareness campaigns foster a security-conscious culture. Proactive security testing, like vulnerability assessments and penetration testing, helps identify and address potential weaknesses. Collaboration within the security community helps create a collective defense against cybercriminals. Mitigating the risk of SQLI requires secure coding practices, robust security measures, continuous education, proactive testing, and active collaboration. By embracing a proactive security mindset, organizations can better protect their valuable data and systems from the threat of SQL injection.